All right, so the recording has started. The topic of today's lecture is, well, we're still implementing classes. Actually, just give me a second here while I take a look at something. Sure, let's do this. So far in the course, we haven't, you've seen the comments or the, you've seen the comments in the code that you've been given for assignment 1 and assignment 2. So before every method or before every class and before every constructor, there's always a comment that's sitting in front of that thing that's in a class, right? And the comments that you've seen, they have a very specific format. That format's actually, it's basically the standard that the Java language uses for documenting code. Now, you've seen in your previous programming courses that you normally document code. You may have been told that there's some sort of format that you should use or some sort of style. So documenting code, it's not an idea that's new to Java. It's not even an idea that was new when Java was invented roughly 30 years ago. 30? Yeah, it's about 30 years ago now. The interesting thing is, though, Java was the first major language to standardize its documentation format and to embed the documentation inside the code and provide a tool that can extract the documentation into readable electronic documents. So the tool that generates your the API documentation from comments embedded in the code is called Javadoc. So this is part of every Java development kit. You get this Javadoc program. So Javadoc processes what are called doc comments. And a doc comment is a comment that's immediately before some class, field, constructor, or method declaration. So those comments that you've been seeing in your assignments and labs, those are all examples of Javadoc comments. So let's take a look at the point 2 class. Now, hopefully I didn't screw this. Okay, so you can see it. Right, so that thing right there, that's a Javadoc comment for the class. Oh, I've collapsed these, sorry. Open these up again. Right, that thing right there, that's a Javadoc comment for the for the no argument constructor. That's a Javadoc comment for the second constructor, and so on and so on and so forth. So in Java, for a Javadoc comment, it always starts with /**. Right, so remember that a multi-line comment in Java starts with /**. Right, so Javadoc identifies Javadoc comments by looking for /**, so an extra star. Right, the compiler doesn't care. Right, so the compiler it treats this as a regular comment and just ignores it. But the Javadoc tool looks for these pairs of symbols that look like that. Your doc comment is allowed to include HTML. So if you don't know what HTML is, that's that's hypertext markup language. So that's one of the standard languages that's used to create a web page. If you don't know what HTML is, it doesn't matter, right? So that's fine for the purposes of this course. Doc comments are made up of 2 parts, right? So in other words, we don't actually use the HTML tags very often when writing the Javadoc comments in this course. So the comment is made up of 2 parts. So there's a description. The first sentence of a description gets copied into the summary section. So I'll show you what that means in a second. There's the description consists of exactly 1 block. So you can use this is the symbol, this is the tag in HTML that indicates a new paragraph. So if you want to, you can separate separate paragraphs of your description using that tag there, right? Otherwise, if you put in blank lines, the blank lines don't get copied into the documentation. So if you want a space between paragraphs, you have to use P, the P tag, the paragraph tag. And then there's a bunch of block tags, right? So these are the things that begin with @ right, inside of a Javadoc comment, right? Now these are different than annotations, right? So we saw the at override annotation the other day. If you've done lab 3, you've seen the at test annotation. These are different than the Javadoc tags. So the tags in Javadoc, these are used to indicate special things that Javadoc is aware of, right? So at param indicates to Javadoc that this is documentation for a method or constructor parameter. At return tells Javadoc that this is the documentation for the return value from a method, and so on and so forth. Okay, so when you go to write Javadoc for your class, then you want to comment. Essentially, you want to comment everything that's public. Right? So Javadoc is meant to document the public features of a class. Later on, you'll see that there are other things you might want to document, but that's for part 3 of the course. So for now, you're going to document everything that's public. So the Javadoc is supposed to describe the public interface for a class or interface, I guess. So every class should have a Javadoc comment that describes the purpose of the class. Now, it describes the purpose of the class. Normally, it does not say how the class is implemented. Right? So normally you don't say the class has a field of type int, or it has internally it has a list that does something or something or the other, right? So normally you don't go into that level of detail, right? So in other words, you don't tell people how you've created the class. You simply tell people what is the purpose of the class. Some of the Java standard library classes do go into great detail on how they're implemented. But that documentation is aimed at other people. It's aimed at people who are who want to who are maintaining the standard library. So it's not aimed at people at regular users. Okay, so in our point 2 class, we should give a description of what this point 2 class is for. Right? So we've got a Javadoc comment before the class, right? And our comment reads, it's a Cartesian point in 2 dimensions having real coordinates. That's basically all you have to say for this class, right? There's not much else you have to say. If you look at the comments for some of the standard library classes like string, right, you'll often see that the doc comment is much more detailed, right? So this, right, all of this is, yeah, there, right? All of that is the documentation, is the class documentation for the class string. And you can see that they tend to go into much more detail than the classes that you'll see in this course, right? But that's because the string class is fundamental to the language, and it's a lot more complicated than our point 2 class. Right? So a description of the class goes here. Oh, sorry. Now, when you run the Javadoc tool, right, to produce your web page that contains the documentation, right, that comment there ends up here. So it ends up in the first part of the documentation. Right. Notice that a bunch of other stuff also shows up in the documentation. Right? And you can tell that the web page that's generated there is different. Was generated from a different type, a different version of point 2 than this one. So this one says it's defined in that package there. The documentation, I didn't bother to regenerate the documentation. It says it's in some other package here. So the package information goes here, class name goes here, the inheritance structure goes here. So you can see this is telling you point 2 inherits from the class java.lang.object. And that's why point 2 has a toString method, for example. And then there's the documentation. Oops, sorry. And then there's the class description. Okay, if you have public fields in your class, then you should document the public fields. Right, so every public field should have a Javadoc comment that describes the purpose of the field. The first sentence of the comment appears in the field summary section of the generated documentation. Now our point 2 class doesn't have any public fields, but the math class does. Right, so if you poke around for the math class documentation for the math class source code, you'll find that there's this field called E, right? So that's Euler's number. There's a field called pi, that's well, that's pi, the mathematical value of pi, right? And you'll see that they have documentation comments that look like this. Every public field gets a doc comment. Right? And when you generate, wait, do I show it to you here? Yeah, right. And so when you generate the documentation comment for the math class, right, you end up with this summary here. Now, just a second here while I look at. Okay, so I should show you something else about fields, because the fields are kind of weird. The documentation for fields are a little strange in Java. Okay, so if we look at the math class, so there's your field summaries. Now, if you click on these things, right, notice that the value isn't here. And often when you have a public constant field, you actually want to know what its value is. So you have to click on that, right? And that still doesn't tell you what the field is, right? It just repeats the documentation. If you need to see the field value, you click there, right? So you click on constant field values, and that will take you to the page that describes the fields, or gives you the values for all the fields for every class in the package. Right, so now you can see that the value of E is that, and you can see that the value of pi is actually that. Right, so it's a little bit awkward to get to the actual value of that field. All right, so if your constructors are public, then they should have Javadoc comments too. So the first sentence of the Javadoc comment appears in the constructor summary part. And then the complete documentation appears in the constructor detail part of the documentation. So there's our point 2 constructor. There's our point 2 no argument constructor. There's its documentation. Right? This particular constructor doesn't need to say anything other than that. Right? So this constructor, the point 2 class just has an x and y coordinate. So all you have to say is what the coordinates of the point are initialized to. Now, you might wonder what this thing is here. So if you write brace, then at code, and then closing brace, everything inside the braces after at code, that gets formatted in a monospaced font. So it gets formatted in like a programming font, right? A programming language font. So for example, oops, where's the, there, okay. So when you generate the documentation for that constructor, right, anything that's in at code inside the braces gets formatted in a font that looks like that, right? So it sets it apart from the regular text font. So if you're referring to parameters or variables or parameters, variables, values, or things like that that you want to set off or highlight using a programming style font, then the way you should do that in more recent versions of Java, well, more recent, in versions of Javadoc that aren't very, very, very old, is to use that syntax there. Now, for this course, I don't care if you do this, right? It actually takes a long time to do. But if you ever get into a job where you where part of your job is to write professional level documentation, then you're going to find yourself doing stuff like this. If you look at the Java standard library documentation, it's written extremely well as far as documentation goes. So it's written incredibly well. And the people who took the time to write that documentation, they spent a lot of time doing it. So that's what would be expected in a professional environment. Here, it's fine. Just write 0, 0 in brackets. It's fine. Don't worry about it. Okay, if your constructor has parameters, then you want to tell the users of your class what each parameter is for, right? So you want to tell people what is the purpose of this parameter, right? And you do that using @param. Now, you do this after you describe the method, right? So you put in the description of the method first, right? Right? So the method description goes first. Then at the end of the description, this is where you document the parameters, the return value, and any exceptions that are thrown. Here's my description of the point 2 constructor that takes in 2 double values, right? So first we tell people what does the constructor do. Don't, again, when you tell people what the you describe to people what the constructor, what the purpose of the constructor is for, right? You don't tell people how the constructor is implemented. You tell people what does the constructor or method do. You don't say how it does what it does, right? So for example, in the description, you do not say it sets the X field of this object to X and it sets the Y field of this object to Y. Right? You simply tell people that it initializes the point so that its coordinates are X and Y. Right? You don't tell people, you don't go into detail on how it actually works. When you describe the parameters, so at param, space, parameter name, right? Space. Short description of the purpose of the parameter. Normally, this is just a one-line point form comment. Right? So it's usually not a complete sentence. It's usually not made up of more than one point. Right? It would be somewhat unusual to give this a very long description. If you need to describe a parameter in detail, then you put it up here. Right? Otherwise, you just want to indicate to people, quickly what is the purpose of this parameter. Now, when you're generating this in Eclipse, you don't have to remember the exact format. So if you're using Eclipse, let me delete the comment for you. Right, so I'm going to delete the comment for that constructor. Right. So if you're on the header of the constructor, you can generate the Javadoc. You can generate the skeleton of the Javadoc automatically. So under source, generate element comment. So Alt Shift J in Windows. Probably, is it the same in Mac? I actually don't know what it is in Mac. But anyway, you get to it from here, boom, and there you go. Right. So it automatically fills in the parameters for your method for you, right? And then you put in a comment. Right. So now you just go ahead, press enter, and you copy in, right, this stuff here. Right. So now you can say X is the value of this point, the X value of this point. Of this point. And that's just the Y value of this point. Also notice the use of the word this, right? So Java programmers are, like an experienced Java programmer knows what this means inside of a constructor or method. So when they're reading the documentation, they kind of expect to see the keyword, that word this, in the documentation as well, right? So people who, Java programmers who are reading this documentation know that when you're constructing the object, that the constructor gets a parameter called this, right? And this refers to the point that's being constructed, right? So when you say the X value of this point, you're saying that the point that's being constructed right now should get the, will be assigned, its X coordinate will be assigned the value X, right? And its Y coordinate will be assigned the value Y. Here's the copy constructor. Right. So again, we're going to document all of its parameters. It has one. So at param, space, name of the parameter. Right. No colon or anything here. Right. So there's no symbols or anything after at param. Javadoc will insert the symbol for you. Right. The tool will insert the symbols for you. So it's just at param, and then the parameter name, and then a short point form description of what. And when you generate the documentation for the constructors, in the constructor summary section, this is what you see. So the documentation for the parameters is not here, right? To get the documentation for the parameters, you have to click on, you have to go to the detail section. Do I show you that? Oh yeah, I do. So here's the constructor detail section. So for the second constructor, right, that's where the documentation for the parameters appears. So this changed in So Javadoc does change a little bit from version to version. It used to be the case that that X there would have been, you'd have to format it differently than using @code. So you can see that when I generated the documentation, this did not get formatted using a monospace font, right? But actually, if you want to get that in a monospace font, you would have to modify. You'd have to go into your documentation. Sorry, and trace at. So it used to be the case that you couldn't do this inside of a parameter documentation, and you'd have to use raw HTML instead. But you can now do that. I think you've been able to do this for quite a while now. Anyway, if you want to format that in monospace font, you have to do it manually. Unfortunately, the tool doesn't do it for you, which would have been nice if it did. And that's the detailed constructor description for the for the copy constructor. So your methods are basically the same, right? So when you document your methods, you're going to describe what does the method do. You're not going to say how does the method do what it does, right? So what does it do, not how it does it. You want to describe every parameter. You also want to describe the return value if there is any, and you want to describe what exceptions are thrown if there are any. Right, so parameters get the @return param tag. Return values are documented using @return. Right, so here's an example of the set method. The documentation for the set method. Right, so that's what the method does. Right, my parameters, new x and new y. Right, so @param new x, @param new y. Right, you don't have to say what the type is because when you generate the documentation, it automatically tells you what the type is. Right, so there's no, you don't have to say the double new x coordinate or something like that. Right, it's just the new x coordinate, y coordinate. For the return, it's @return space and then a point form description of the return value. This one says it returns the reference to this point, and that's it. That's all you have to do. Right. If you need to describe the return value in detail, right, again, it goes up here. Right. This is just a quick summary of what the return value is. Right. And so when you generate the documentation for the set method, it ends up looking like this. Right. So you can see that the type of new x is double here. Right. So you don't say down here that this is a new double x coordinate. See that the return type up here is 0.2. So you don't say a reference to a 0.2 object, right, or something. A reference. This is old documentation. This is the new x coordinate, a reference to this point. If a constructor or method throws an exception, then you should document the exception. So what type of exception is thrown and the conditions under which it is thrown. Right. That gets documented using @throws. Right. And you've seen these already, right, in your labs and assignments. So the counter constructor throws an exception if that value is less than 0, right? Because the counter is can only count non-negative values. So to document that exception, you write @throws, name of the exception, and then a short description of when the exception is thrown. Right? So if the value is negative. If you want to write math here, that's fine, but you have to put it in. Oh, I should tell you. Yeah. Okay. I should tell you that actually. This is the where basic. So I want the counter class. Where is that exception? Is this the wrong version? Oh, wrong version of the counter class. Okay, hang on. Notes. I have to go to a more complete version of the counter class. Here we go. Okay, so what you really want to write is if value is less than 0. Right? Unfortunately, you can't do that. Right? So you have to be on the lookout for this thing here. The problem with Javadoc is that it's actually HTML, right? So in HTML, HTML interprets that as the beginning of an HTML tag. So if it sees a less than or a greater than sign somewhere in your documentation, Javadoc barfs. It says it's like, I forget what the error message is, but it tells you that it's an unknown tag or an incomplete tag or something like that. Right. So when you find yourself wanting to write that, you have to wrap it up in @code. Okay. So that would be another way to write it. And that's probably, oops, sorry. And that's probably the way that you would write it. In what happened? Oh, wait, did I close it? Sorry. Okay. And that's probably the way that you would write it normally. Now, when you see the documentation for the assignments, I normally don't spell out that condition mathematically. So normally I write it out in English to force students to interpret the English and write the correct and come up with the condition on their own. Right. So when you read my documentation, it normally isn't written like this. Right. So it's normally written. Undo that? I can't undo that. It's going to be written like this. So if the value is negative. Right. And so that's to force you to interpret that like that. Okay, so when you generate the documentation, right, now your exception gets documented like that. Right, so there's a throws section that appears, and it tells you the type of exception and when it's thrown. If you know HTML, you are allowed to use a subset of HTML tags in Javadoc comments. Right? If you don't know HTML, don't worry about it. Fine. It's common to use the paragraph tag to if you have a long comment. Right. So here's the add here's the add method in our point2 class. We haven't implemented this yet. If you look inside the point2 class, you'll find a bunch of methods that we haven't talked about yet. So this method here. You have a point. This is in the point2 class, right? So this is a method that adds a vector to a point, causing the point to move. Right. So a point here, I've got a vector like that. I add the point in the vector, I end up with the point here. Right. So in other words, I end up at the tip of the vector. So the comment here says it adds a vector to this point, changing the coordinates of the point. Right. And then down here, there is more detail about when you should use this method. So you use this method when you want to write something that looks like P equals P plus B, right? Where P is the point that you're calling add on. Okay. Sometimes you want to create a new point, right? So sometimes you want to write Q equals P plus B. For that, you call a different version of add. So we use the P, the HTML P tag here to indicate a new paragraph. Right, and when you generate the documentation, right, you see that Javadoc inserts a new paragraph into the documentation. You can also do things like lists, which are often useful. And there's a few other things you can do, but you can't use all of the HTML tags. And I don't know if you know what a CSS is. I don't know if you can describe the style of your inserted element either. I suspect not. Now, if you plan on writing Java code professionally, then at some point you should actually hit that link there, because there is actually a document that goes into great detail on how you should actually write these Javadoc comments, including like including grammar rules and things like that that you should use when you write your comments. Okay, so that's the quick introduction to Javadoc. In lab 5, I think, I'm going to show you how to use the Javadoc tool to actually generate your documentation and how to look at it. Right. But for now, you just have to know how to write. You have to start to learn how to write your own Javadoc code. Now, I should warn you, it takes a, Noah, so It turns out that the Javadoc tool does not like the closing tags. It's just the way that the tool works, right? If you insert the closing tag, I'm pretty sure Javadoc barfs. At least it used to. So normally you don't insert the closing tag. But that's the reason. It's because the tool doesn't like it, right? It doesn't actually support the full HTML standard, because that would be actually really hard to do. But yeah, normally you don't include the closing tags for paragraphs. Pretty sure anyway. Right. Okay. Now I should warn you, if you get an assignment and it says Javadoc all of your methods and constructors and the class, it will often take you almost as long to write the Javadoc as it will to write the code itself. Writing the Javadoc takes a long time, which is one of the reasons why a lot of programmers don't like doing it. It takes a lot of time. It's not especially fun, right? And to do it well is actually very hard. But anybody who's using your classes will appreciate well-written Javadoc, well-written documentation. The Java standard library documentation is actually very pleasant to read as far as documentation goes, right? I'm not saying it's pleasant to read in general, but it's nice to read as far as documentation goes. If any of you have programmed in Python and you've tried to read the Python documentation, that's much less pleasant to read, I think. At least the standard documentation. The Java documentation is much better to read. All right. I should point out another thing. That's also the reason why on most of your assignments, I don't ask you to write the Javadoc, right? I'm going to ask you to do it once, and that's it. I'm not going to force you to do it over and over and over again. It really takes a long time to do, and I don't really think it's. It's something you have to learn how to do if you're going to program in Java, right? It's something you should do in general if you're programming. But making you spend hours and hours and hours writing documentation, I don't see the point of that, right, when you're busy doing other things. Okay, preconditions and postconditions. So we're back to implementing methods and constructors. Some methods and some constructors require that one or more conditions be true before the method or constructor is run. Right? And you've actually seen this already in assignment 2 anyway. Right? Assignment 1, 2, I think you had some exceptions. Yeah, you threw exceptions if there were some conditions that weren't met. Right? So you've already seen this. Now I'm telling you what it actually means. Right? So a method can have what's called a precondition. So a precondition, there's a reason it has this name, right? So it's a condition, something that's true or false. That the caller of the method must ensure is true before they call the method. Right? Caller of the method that's responsible, right? So whoever is using the method, it's their responsibility to ensure that when they call the method, they satisfy the preconditions of the method. So what's an example of a precondition? Well, our point2 class has this method called divide in it. Point 2. Oh, where is it? Divide. Okay. So the point2 class, its divide method takes in a double value, and it divides the coordinates of the point by that scalar value. Right. So it's like taking the point and multiplying it by 1 over s. Now, what is the precondition on the method? If you're dividing a double value by another double value, well, that second double value better not be 0, right? Unless you are willing to live with infinity, right? If you're willing to live with positive or negative infinity, or not a number, if you take if it's 0 divided by 0 is not a number in floating point. If you're willing to live with those, then that's fine, right? Our point2 class is not willing to create a coordinate whose value is the point2 class is not willing to divide the coordinates of a point by 0. So we check. If s is 0, throw an exception, right? So the precondition for this method is the opposite condition of when the exception is thrown. Okay. So the precondition for this method is that s must not be equal to 0. Right? If s is equal to 0, then dividing the coordinates of the point might produce an error. Right? So our divide method does not allow that s be equal to 0. Right? So that's the precondition for the divide method. Okay, so if you have a method that has a precondition, and it's actually very common that you have one of these things, right, then the precondition should be documented in the documentation for the method. Right? Now, unfortunately, Javadoc has no dedicated tag for preconditions. So the precondition has to be documented in the method description, or in the parameter description, or in the exception documentation, if the method throws if the method chooses to throw an exception. So here's a different version of how you might document divide. Right. So instead of throwing an exception, you might indicate that the parameter s must not be equal to 0. Similarly, you could indicate it up here, or you could indicate it here. But somewhere it has to be documented, because whoever's calling this method needs to know that s can't be 0, otherwise something bad might happen. Let me just show you the version. So in the version that's in the notes, right, it's documented slightly differently. Right here, it's documented via an exception. Right, any of those are acceptable. Right, now you'll see why. I think you'll see why I chose to document it this way in this example. Okay, so who's responsible for satisfying the precondition? It's the caller of the method that's responsible for satisfying the precondition. Right? So that means whoever's writing the divide method, so whoever's writing this divide method here, they get to assume that the precondition is true. They get to assume any preconditions that are on the method. Okay, so for the divide method, that means whoever's implementing divide can assume that the value of s is not 0, right? And then they implement the method with that assumption in mind. Okay? So it's not the responsibility of the implementer of the method, right? It's the responsibility of the caller. So in divide, right, you can simply ignore the case where s equals 0 is true. Right? So as the implementer of divide, I can simply say, hey, s is not 0. I'm just going to divide. I'm just going to go ahead and implement it like that. And that is technically fine. It's technically fine. So what happens if someone calls divide with 0? Well, something bad happens, but it's the caller's fault. So in other words, it's not the responsibility of the implementer in this case, right? Because we told everybody, hey, this can't be equal to 0. And as C programmers, that's pretty much what you're used to doing, right? Because all of the C standard library functions, a lot of them will tell you, hey, the input can't be null, or the value can't be 0, or something like that, right? And the documentation for the function will say it's unspecified behavior if you know, if the input is null or something like that happens, right? So the C standard library functions, they basically say, hey, it's your problem if you call the method wrong, the function wrong. Now the problem with doing this, right? So there's a big problem with doing this. So the problem with assuming that the precondition is true is that your method still runs with invalid inputs, right? So in divide, if I just assume s is not 0, this will always run, right? Even if s is equal to 0, right? And if s is equal to 0, that's either positive infinity, minus infinity, or not a number, all of which might be unacceptable, depending on what you're using the class for. Okay. So all the code in your method runs, and that can lead to bad things happening. Right? So for example, your method might end up returning the wrong value if it returns a value. Right? The method might encounter some sort of unexpected error. Right? So in other words, the method might end up throwing an exception that no one's expecting. The method might not be able to complete everything in its contract. Right? So every method says that it does something. Right? So it may not be able to do everything if it runs into some sort of error because a precondition wasn't satisfied. Right? And then finally, perhaps the worst thing that might happen is that the method ends up putting the object into an invalid state, which is what basically happens in C. But you kind of want to avoid doing that in an object-oriented programming language. So for example, right, if I take this point here, divide it by 0, you end up with infinity and infinity. Is that correct? Well, it might be. Right? It depends on what you're using or what you're designing the point2 class for. Okay, so if you have a public method, then normally what happens in Java is that the preconditions are checked before the body of before the rest of the method runs. Right, and so when you check them, you if the preconditions are not satisfied, then usually what happens is that an exception is thrown to indicate that the precondition has not been satisfied. That's not always what you do, but normally that's what you do. So what's an exception? Well, now I'm finally telling you what an exception is. Right. So an exception is shorthand for what's called an exceptional event. So when an error occurs within a method, the method creates an object. So this is what exceptions actually are. Right? So the exceptions are actually objects. Right. That's why you write throws new illegal argument exception. Right. You're actually making an object of type illegal argument exception. Okay. So you make an exception object. That exception object gets handed off to what's called the runtime system. Now, for our purposes, that's just the Java virtual machine. So that's the virtual computer that your Java code is actually running on. That object contains information about the error. So when you make the exception object, you're allowed to include a string that describes why the exception was thrown. Right? But it turns out there's also more information encoded in that object. So the information that you get, the type of exception, might get the state of the program when the error occurred. So if you've gotten an exception in one of your programs when you run it, you'll notice that there's actually a lot of information that's printed out when the exception is thrown, including the line number which caused the exception to occur. So that's all useful information when you're debugging. Creating the exception object and handing it off to the runtime system, that's called throwing an exception. Right? So that's why we use the keyword throws to throw an exception. Right? If you want to learn more, click that link there. Right? So to throw an exception, you make an exception object, right? And there's lots of different exceptions. I should show you those. So there's tons of standard exceptions. All right? No, I got that wrong. Java 8. No, it's in lang, of course. Okay, so these are all the standard exceptions defined by the Java standard library. Right, so there's a lot of them. Sorry, these are all the ones that we would throw for now. There are other ones as well. There's a legal argument exception right there. Okay, so that's a common one. You had to throw an index out of bounds exception, I think. Or an index out of bounds exception was thrown in assignment 2, so there that one is. Right, and there's a whole bunch of other ones that you can choose from. You can also define your own exceptions as well. So if you want to, I guess later on in part 3, you'll know enough to define your own exceptions as well. Much more of this. Okay, so there's just a couple more slides. you also know this, right? So when you make the exception object, if you want to throw the exception, you use throws to throw the exception, right? When you throw an exception, what happens is your program immediately stops running, right? So at the point that the exception is thrown, the method or constructor immediately stops, right? Any code after the throw statement does not run, guaranteed not to run. Now, what does that mean? That means you should always check the arguments first and throw the exception before modifying the state of the object, right? So in other words, if you have a method that or a constructor that, well, let's do constructors. When your constructor sets the state of the object, right, you check the preconditions first, throw an exception, and then after that set the fields of your object, right? You don't set the fields of the object first and then throw an exception. Because what ends up happening there is you end up with a, you potentially end up letting the caller get an incorrectly constructed object, right? If you throw the exception first, then the caller never gets an incorrect, there's no way for the caller to get an incorrectly initialized object. So in the divide method, right, if s is equal to 0, throw the exception. All right, so that's enough for preconditions. I'll tell you about postconditions, I guess, after reading week, because your midterm is tomorrow. Does anyone have any questions about today's lecture? I guess, or the midterm or assignment. Well, I guess you can't hand in assignment 2 anymore. But if you have questions about assignment 2, I can still answer them. I'll post the answer right after this lecture. Anybody? Lab 3 is due. Yeah, it's due after reading week. I don't want you to have to do, like, you have to do an assignment this week. You have a midterm this week. I don't want you working on the lab this week either. Okay. So do lab 3. Lab 3 is due after reading week. Yeah. Anything else? All right. Thanks for coming out this morning, everybody. I will see you. Well, I won't see you during the midterm tomorrow.